Okay, so today we are going to continue our look into probability by looking at sample spaces, tree diagrams, and the fundamental counting principle. So we're going to be looking into different ways of doing theoretical and experimental probabilities. So first we're going to start with a little bit of a warm-up to help us review what we worked on yesterday, which was experimental and theoretical probability. So our first question is, Kim scored 3 out of 5 shots that she took. What is the experimental probability that she will make a shot? So you're going to write your answer as a fraction and as a percent. So your experimental probability, so you had 3 favorable outcomes out of 5 total trials. So your experimental probability would be 3/5 or 60%. Number 2, Cameron rolled 4 5s out of 18 rolls on a number cube. What is the experimental probability? What is the theoretical probability? So remember, write each of them as a fraction and a percent. So our experimental probability would be 4 out of 18, and our theoretical, we're working with a number cube, so there's 1 5 on a number cube out of 6 sides. So our experimental would be 4/18 or 2/9, which is 22%. And our theoretical is 1/6, which is 17%. Number 3, Steve runs 4 out of 7 days a week. What is the probability that he will run on Monday? So we take our number of favorable outcomes out of our total number of trials. So for our total number of trials is 7 days. So how many days did he run? He ran 4 days, so 4/7, which equals 57%. Okay, let's start out with today's lesson with a little bit of vocabulary. So our 2 new vocabulary words that we're going to start with is sample space and tree diagram. So sample space is all of the possible outcomes of an experiment. You can use a tree diagram to show you all the possible outcomes of the sample space. So today we'll be learning how to create a tree diagram to show our sample space. An example, Jake tosses 3 pennies. Find all the possible outcomes. Make a tree diagram. So when we're making our tree diagram, our first step is to think about our theoretical probability. What are all the outcomes of tossing a coin? So tossing a coin, we have the 2 outcomes. We have heads or tails. So that's going to be our starting point for our tree diagram. So Jake tosses 3 pennies. So we need to run this trial 3 times to find all of our possible outcomes. So for heads, he can do 2 different things after flipping a heads. He can then flip a heads again, or he can flip a tails. For tails, he once again has 2 new outcomes. He can flip a heads, or he can flip a tails. So this is what happens on our first flip. These are the things that can happen on our second flip. Now we need our third flip. So we have to go with our first thing. So he could flip a heads, then he could flip a heads, then he can do two different options again. He can flip a heads again, or he can flip a tails. He can flip a heads, he can flip a tails, or he can flip a, then he'll have his two options, heads or tails, for his third flip. Same with our tails. So we have tails, heads, and then he can flip a heads or a tails, tails, tails. Then he can flip a heads or a tails. So now we have all three of our flips. We have our first, our second, and our third flips. So now we have all of our possible outcomes. So now we can count how many possible outcomes we have. We have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes of that Jake could get from tossing 3 pennies. So find the probability of all 3 tosses will show heads. So we're going to look for heads, heads, heads. So you can see that that only happens right here. So it only happens this one time out of our total number of outcomes, which we counted 8 total outcomes. So our probability would be 1/8. So now I want you to try. Make a tree diagram for each, tossing a coin and rolling a number cube. And then choosing black, blue, or brown socks with boots, gyms, or dress shoes. So we're going to do, I want you to do this one on your own, and then we'll go over this one together. So tossing a coin and rolling a number cube. So for these, we start with 2 options. So our first trial is tossing a coin. So there's 2 different options for tossing a coin. We can do, we can do heads or tails. Then we are rolling a number cube. So there's the possible outcomes are 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6 different outcomes for heads. So let's see, tails would be 1, 2, 3, 4, 5, and 6. So we have a total of 1, 2, 3, 4, 5, 6. So we have a total number of 12 outcomes. So what would be the probability of tossing a head and rolling a 4? So tossing a head, whoops, rolling a 4 happens 1 time. So it'd be 1/12 would be our probability. So we would have 1 out of 12. What about choosing black, blue, or brown socks? So our first option would be, that's not one. Why did I change my color? Black, blue, or use this for brown. Or brown socks. Then we have our next option with boots, gym shoes, or dress shoes. So each of those is going to have 3 different options. So we have boots, gym, or dress shoes. And that's going to be the same for all 3 sock options. So if we look at it now, we have 3 different options. We have boots, gym, dress. So we have 3 options for black socks, boots, gym, or dress. We have 3 options for blue socks, boot, gym, or dress. We have 3 options for our brown socks. So we have a total of 9 outcomes. So our sample space has 9 outcomes. So that's how we use a tree diagram to determine our sample space. Now we're going to look at another way to determine our sample space or our total number of outcomes. You can find the total number of outcomes for 2 or more experiments by multiplying the total outcomes for each individual event. So you're going to multiply our total outcomes for each individual event. So let's look at it. Jack wants an ice cream. He can choose a cone or a cup with vanilla, chocolate, strawberry, or strawberry ice cream. How many types of ice cream can he buy? So his first option is cone or cup. So his first option has 2 possible outcomes. Then his second option is vanilla, chocolate, or strawberry ice cream. So his second option has 3 possible outcomes. So we're going to take 2 times 3 to get 6 possible outcomes. Example number 2. A steakhouse offers the following choices for a steak dinner. How many different dinners are possible? So our first option is our steak. So we have 1, 2, 3, 4 different types of steaks that we can choose from. So we have 4 different steaks. Then we have how they are prepared. So you can choose rare, medium, or well. So we have 3 ways that they are cooked. Then you have your possible sides. You can choose for potatoes. You can choose mashed, baked, sweet, or fried potatoes. So you have 4 different ways that these potatoes can be prepared. So now we're going to multiply each of our different options. So we're going to take 4 times 3, which is 12. Then we take 12 times 4, which is 48. So we have 48 different dinners that they can choose from just by having these 4, 3, and 4 different options. So it's your turn to practice using our fundamental counting principle. Number 1, we're tossing a quarter, a dime, and a nickel. So what is the probability, or how many different outcomes can you have for tossing a quarter, a dime, and a nickel? So you can do heads or tails for a quarter, heads or tails for a dime, and heads or tails for a nickel. So you have 8 outcomes. Number 2, choosing scrambled, sunny side up, or poached eggs with bacon or sausage, and milk, orange juice, or apple juice. So how many different breakfast combinations can you make given those options? Okay, so our first option has 3 different options. Our second choice has 2 different options, and our third choice has 3 different options. So you're going to take 3 times 2 times 3 to get 18 total outcomes. And number 3, rolling a number cube and tossing 2 coins. How many outcomes would you get? How many different outcomes would you get? So we have 6 total outcomes for our first option. And then we have two options. As we rolled our number cube, we tossed our first coin, we tossed our second coin. So we have a total of 24 outcomes. So your closing thought today is compare using a tree diagram and using the fundamental counting principle to find a sample space. What are the similarities? What are the differences?